In 2017, Hurricane Harvey moved towards the Texas coast, stopped dead in its tracks, spun in circles, and dumped over 50 inches of rain in the same spot. It was not an isolated incident. Extreme examples like Hurricane Ivan in 2004 looping back down to Florida, Cyclone Hyacinth in 1980 doing loops west of Reunion, or Typhoon Wayne in 1986 zigzagging across the South China Sea for 21 days show just how bizarrely these storms can behave. So why do tropical cyclones follow such erratic paths? Before we dive into the weather science, make sure to subscribe to the channel so you never miss another deep dive into our planet's wild weather. Under ideal conditions, predicting a cyclone's trajectory is straightforward. High pressure systems near the tropics push the storm west, while the Earth's rotation nudges it towards the poles into mid-latitude winds that curve it east. However, a storm's intensity continuously alters its movement. Weak cyclones are shallow, steered strictly by surface winds, but as a storm intensifies over warm waters, its convective core towers into the upper atmosphere. Because upper-level winds often blow in different directions, a strengthening storm will catch these higher currents and take a sudden hairpin turn, like Hurricane Joaquin suddenly veering southwest near Turks and Caicos in 2015. Conversely, if strong vertical wind shear rips the top off a storm, it collapses into a shallow system again, reverting back to surface-level steering. Things get even more chaotic when primary steering winds collapse entirely, leaving storms to stall out or drift on internal momentum. If two cyclones wander within about 900 miles of each other, they perform the Fujiwara effect, an atmospheric dance where the systems orbit a shared center point. Depending on their size, they can deflect each other, throw off erratic loops, or merge into one. A classic modern example caught on satellite imagery is 2021's tropical cyclones Seroja and Odette off Western Australia, which slung each other around in a counterclockwise orbit before Seroja absorbed the weaker storm. Because a cyclone's journey relies on shifting sea temperatures, multi-altitude wind shears, and surrounding pressure systems, forecasting their exact path remains a major meteorological challenge. With so many atmospheric variables at play, the ultimate rule of storm tracking is simply expecting the unexpected. I hope you found this informative and interesting. Be sure to subscribe to support the channel. Here's a video you may like.